Welcome. So the topic we'll be discussing in this lecture is process management. As already discussed, operating system is also called as resource manager because it manages several resources. So one of the resource that it manages is process. Like that, it manages memory. As it manages memory, it is called as a memory manager. As it manages processes, it is called as process manager. As it manages IO devices, it is called as a device manager. Okay, so the topic of this lecture will be on process management. So already we have defined what is a process. A process is a program under execution. For example, a compiler that is running is called as a process. A word processing application that is currently in the memory and which is being executed, that is called as a process. Okay, so here I would like to emphasize the difference between program and process. A program is a passive entity, whereas process is an active entity. As long as the file resides in the disk, it is called as a program. The moment the file was brought into memory and when it is allocated some resources, from that point onwards, it is called as a process. Okay, so the definition is a process is a program under execution. And every processor needs certain resources to execute. Okay, the resources includes CPU time, memory, or it may want to access some IO devices, or it may want to access certain files. So the resources that were required by a process can be classified into two categories. The resources that were required by a process can be classified into two categories. Okay, one is called as physical resource, the other one is called as the logical resource. Okay, so for example, if you see CPU time, CPU, memory, IO devices, all these comes under physical resources. Okay, when you for a process to execute, CPU should be allocated. Okay, and it needs some memory location. It needs some space in the memory, and it may want to access some IO devices like keyboard, mouse, or printer, whatever it may be. So these are all the physical resources that were required by a process. Similarly, sometimes the process may also want certain logical resources. Say for example, a process may want to access a file which is stored in the disk. Okay, say there is a file which contains some data and the process want to access this particular file. So now say the file name is log file. Okay, so let us call the file name as log file. Okay, maybe it is log file dot text. Okay, now this log file dot text, this is not a physical resource. You cannot it is not any physically, you cannot see it. So this type of resource are called as logical resource. Or sometimes a process may want to uh, get input from another process, or it may want to interact with another process. Okay, so it may interact with another process. So current process may be current process whatever it is running may be P1, and this process P1 may want to interact with another process P2. So in that case, P2 is also called as a logical resource. Okay, so the point is any process needs two types of resources. It may be physical resource or logical resource. So what are the physical resource? CPU, time, memory, IO files, IO devices, all these comes under physical resource. But if the process want to access any file or it want to communicate with another process, then all these comes under logical resources. Okay. In addition to this, when a process is being executed, it may sometimes what happens in the sense the process some process may have to be initialized with certain parameters. It is not the case in all the process. At some cases, the process may need to be initialized with certain initialization parameters. So in that case, the process may require some initialization parameter. Okay. So what is meant by initialization parameter? Say for example, there is a process which displays the status of a file. Okay. Let us call this process as P3, and what it does in the sense it displays the file status. Okay. So the job of the process is to display the status of a file, whether the file is, maybe it may display there whether the file is currently opened or not, whether it is a read file, whether the user is having the read access to the file or write access to the file, or how many lines of data the file contains. All these things this process may provide, but before starting the process it may need a initialization data. What is that? For example, say this is the system call. So to invoke that particular process which displays the status of a file, then it may need some initialization parameter like path, in which path the file is stored. So if it is stored in E drive, say what do you call E drive, some folder name. Okay, E drive all files, and there again you should it should also, it may also require a file name. Okay, so you should, so this particular process it needs two parameters. What parameters it needs? It needs the path and the name of the file. Once you give this path and name of the file, and if you call this particular system call, then it will display the status of the file, like what is the name of the file, how much size it occupies in the disk, currently is anybody is using the file or not, if somebody is using, are they having write access or are they having read access, what is the size of the file on disk, all these information you will be getting. Okay. So the key information is every process needs certain resources, and these resources may be physical resource or logical resource, and in some cases before invoking a process, the process may need some initialization parameters. So these are some examples of initialization parameters. Maybe it may require the path name and the file name. Okay. Okay. So the process, what it will do, it will be kept in the main memory, and the CPU will execute the process in a time sharing fashion, and obviously after certain period of time the process will come to a termination point. It means the process has finished execution. The moment the process is terminated, then what the operating system will do in the sense, operating system will reclaim if there is any reusable resources. Okay. So for example, memory is a reusable resource because that process may be occupying some amount of memory. Say assume the process P1 is currently executing. Okay, but after say X amount of time, P1 has terminated. And if P1 is occupying 3 MB of memory, then what the operating system will do? Operating system will reclaim this space because operating system may use this memory space for some other purpose. Okay, so that is what is called as so whenever a process terminates, the operating system will reclaim all the reusable resources. Okay. And another important point is these resources may be allocated either when the process is getting created or during the execution of the process. Okay. For example, if you see memory will be allocated the moment the process is created because it needs some space. Okay, so the memory will be allocated to the process the moment the process is created. Okay, so whenever the process is created, then immediately memory will be allocated. But if you see this IO access, initially the process may not require any IO access, most probably. So while executing, say the process is the process execution time is say 50 milliseconds. It is 50 milliseconds. It is going to reside in the main memory and it is going to execute. Okay, while executing, maybe during 20th millisecond, it may want to access the keyboard, or it may want to access the monitor. Okay, maybe then it will access the monitor during that time only. So maybe from 20th millisecond to say 25 millisecond, it want to access the monitor. Then it will access during that time, and then it will give back the resource. Okay, so it means that some resource will be allocated when the process is getting created, and some resource will be allocated and retrieved during the execution of the process. Okay, and every process, when a process is being executed, every process will have something called as a program counter. So what is meant by a program counter? So this program counter is a very important concept which we'll be using throughout the course, and also you will be using this throughout your computer science career. So what is a program counter? A program counter is something which contains the address of the next instruction to be executed. It always holds the address of the next instruction to be executed. Okay, so say 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 a process is currently in the memory. Assume it is stored from the location 1000 to 1050. Okay, it is stored in the location 1000 to 1050. That is, it is occupying 50 locations in the main memory. Okay. So this is main memory, and main memory is divided something like this, and this process is occupying 50 locations. Now what will happen in the sense, initially program counter is basically a register. It is a register which is placed inside the CPU. Already we have discussed about registers. Registers are kept inside the CPU. So this program counter currently, what it will have in the sense, it will have a value 1000, because initially the program is just loaded in the main memory. So what is the next instruction to be executed? The instruction which is in the location 1000. Okay. Now assume that CPU started executing the program, and CPU is fetching the instruction which is, so CPU will, how the CPU know which instruction should I execute? For that, first CPU will refer program counter. What is in program counter? 1000. So this is the first step CPU will do. Program counter contains 1000. So it will go to that particular memory location and it will fetch that instruction and it will execute. That is the second step it will do. Okay. When the CPU is executing this particular instruction, when the CPU is executing this particular instruction, by the time, what will happen in the sense, program counter will automatically increment. Program counter will automatically increment. So this 1000 will become 1001. So this 1000 will become 1001. So after completing execution of this particular instruction, again CPU will check now what is program counter. Now it is 1001. So it will execute 1001 instruction. Again, when this is being executed, program counter will become 2. So after completing 1001 instruction, once again program counter, CPU will check now what's the value of program counter. It is 1002. So next it will fetch the instruction from 1002 and it will execute. So this is how it continues. Okay. So finally at one point, program counter will have a value. What value it will have? It will have a value 1050, which is the address of the lost instruction. So at one point, program counter will have the value 1050, which is the address of the lost instruction. So CPU will fetch that instruction and it will execute. Okay. So I mean, after executing all the instructions, program counter will increment, and at one point it will become 1050. Okay. So during execution of this instruction, what program counter will become? Program counter will become something like, say it may become end of file or -1 or whatever it may be. Okay, it may become -1. Let us assume it becomes -1. Now the CPU once again comes and checks what is program counter. It is -1. -1 means what? There cannot be a negative address. Okay, so -1 represents end of file. That is, you have reached the end of that particular process. It means the process has finished execution. So now the CPU will understand that there is no more instructions to execute. Okay, so this is the role of the program counter in an operating system, right? So if you have multiple processes in the memory, if you have more than one process in the memory, then for each process there will be a program counter. For example, to refer to this particular diagram, here you can see that there are multiple processes. There are more than one process. Job 1, job 2, job 3, job 4. So what happens? The operating system will context switch from job 1 to job. The operating system will execute job 1 for some times. Say it may execute job 1 for 5 milliseconds, and it may execute job 2 for 7 milliseconds, and it may execute job 3 for 8 milliseconds. Like that it will context switch. Okay, so here what happens in the sense, there will be a different program counter for different jobs. For job 1 there will be a program counter, let us call it as PC1. For job 2 there will be another program counter, say PC2. For job 3 there will be another program counter, say PC3. Okay, so like that it will be maintaining different program counter for different jobs. So maybe it is PC4. Okay, so initially if the processor is executing this particular job, then it will check what is the address in PC1. So that address it will execute. Okay, then it will continue to check PC1 for 5 milliseconds. Once this 5 millisecond is over, the processor has to shift to the next job. So it will just stop that. Then it will check PC2. What is the value in PC2? And then it will execute that instruction, and it will continue here for 7 milliseconds. After 7 milliseconds, it will go to PC3, maybe PC3 for 3 milliseconds. Then it will keep checking PC3. It will execute the whatever the value that is whatever the address that is stored in PC3. It will fetch the instruction from that location and it will execute. After executing, completing that round for job 3, then it may check the whatever the value stored in PC4, and it may keep checking PC4 for another 2 milliseconds, and whatever the value available in this particular program counter, it will execute. So here PC stands for program counter. Then once again it will switch to job 1. Okay, so this is how in a multi-processing system the things works. Okay, so that is, you will not have one program counter, you will be having more than one program counter, and depending on the will be having more than one program counter, and depending on the requirement, the processor will check the appropriate program counter, and it will fetch the respective instruction and it will execute it. Okay, so this is how, this is the role of the program counter. Okay, hope you got the idea. Okay, so then there is something called as, so see, normally any program will execute sequentially unless and otherwise there is a requirement to change the sequence. So sequence in the sense, normally the program will execute one instruction after another instruction. Okay, so that is, after executing first instruction, it will execute second, then third, then fourth, like that. Okay, so there are certain situations under which the sequence may change. So maybe when there is a loop, or when there is a subroutine call, something like that. Okay, And there is another concept called as threading, multi-threading. Okay, so what is meant by multi-thread? So you know about multi-processing. Multi-processing means having more than one process in the memory simultaneously at the same time. Okay, and the processor will switch from one process to another process. So that concept is called as multi-processing. So there is another concept called as multi-thread. What is meant by multi-thread? Multi-thread in the sense, again I will go back to that particular diagram. So here if you see, sorry, here if you see, so this is one process, this is another process, like that we have many processes. Okay, so there are 4 processes available in the memory currently. Okay, but each of this process can have multiple thread. So for example, job 1, otherwise we call it as process 1. Job 1 may have 3 threads running parallelly. Job 1 may have 3 threads running parallelly. So one example for threads are, say for example, this process job 1 or process 1, say this is a word processing application. This is a word processing application. So you might have used word processing application. So in the word processing application, if you see, there is an automatic spell check. So whenever you type something, there will be some program which will be automatically checking the spelling. So what does it mean? It means that there are 2 threads running parallelly. There is a thread 1. There is a thread 1. This thread 1, what it does, there is a thread 1. This thread 1 is taking the user input. Whatever you are typing, it is taking that input and it is displaying in the screen. So this is controlled by thread 1. And at the same time, there is another thread. So this thread, it just whatever the user is typing, so that it is displays. There is another thread 2, and this thread, what it does in the sense, this thread, it is used for spell check. So whatever things you are typing, it is checking. Okay, so it means in single process you have multiple threads, and these threads are executing parallelly. Again, how it happens? For example, let us assume here CPU is allocating 5 millisecond or 6 milliseconds for this process. Okay, CPU is allocating 6 millisecond for this process, and say 4 millisecond for this process, and 3 millisecond for this process, and say another 3 millisecond for this process. Now the first process has 6 millisecond. Now within this process, what it will do in the sense, this process itself, what it will do in the sense, it will give first 3 millisecond for thread 1 and next 3 millisecond for thread 2. Like that it will context switch. Okay, but this context switching between threads is not controlled by the operating system, whereas it is controlled by this process itself. So this process has 6 millisecond time. Out of this time, it is giving 3 millisecond for thread 1 and 3 millisecond for thread 2. So who is making this switch? This switching is done by the process. Operating system don't know about this. Operating system just gives 6 millisecond time for this thread, but internally it divides into 3 millisecond and 3 millisecond. So this concept is called as multi-threading. So how do we define thread? Threads are called as lightweight process. Threads are called as lightweight process. So what is meant by lightweight process? Why it is called as lightweight? Generally, process is a heavyweight activity. Heavyweight in the sense, the context switching from one process to another process, it is done by the operating system. It is done by the operating system. So whenever an operating system does, that becomes what task? That becomes a kernel mode operation. So initially when the process is getting executed, when say this process is executing means it is in user mode. Now during context switch, it has to convert it to kernel mode. Then from user mode, it will go to kernel mode, and then it will perform context switch, and then once again it will come back to user mode. So all these are costly operation. Costly operation in terms of time and resource request and allocation. Okay. Whereas switching within a thread is not controlled by the operating system, it is controlled by that particular process itself. So here if you have two threads, thread 1 and thread 2, so if you are switching from one thread to another thread, that is not controlled by the operating system. So it is controlled by this process itself. So it is actually a lightweight task. So no operating system is involved here. It is already in the user mode, and in the user mode it is switching from thread 1 to thread 2, so on and so forth. So it actually does it very fastly and in a seamless way. So threads are, because of these reason, threads are called as lightweight process. Okay. So let us not go much deep into threads. Later we will be discussing in detail about this. So as of now, what should you understand in the sense, a thread is a lightweight process. It is similar to a process, but it is a lightweight process. So a process can have multiple threads, and context switch between the threads is done by the process itself, whereas context switch between process from one process to another process will be done by the operating system. Okay. So so that is the core idea about process management. So as a part of process management, the operating system may perform the following activities or following tasks. The operating system may be creating and deleting user process and system process. User process are the one which contains user codes. System process are one which contains system codes, operating system codes. So the operating system may create either a system process or it may create a user process. And also it has the privilege to delete any of these processes. And operating system may suspend or resume a process. Suspend means stopping a process or halting a process temporarily. Resuming means continuing it from the halt stage. It may continue at some point of time. And also operating system performs something called as process synchronization. What is process synchronization? Process synchronization means, say for example, two processes want to access a shared memory. So this particular memory, piece of memory, and there are two processes, process 1 and process 2. So both of them say that we want to access this particular memory. Then it is the job of the operating system to decide who can access and when they can access. So this concept is called as process synchronization. So the operating system helps these two processes to get synchronized so that they can access that particular shared memory or any other shared resource without any conflict. And also operating system provides mechanism for process communication. Sometimes one process may want to communicate to another process. Process 1 may want to give its output to process 2, which may be taken as an input by process 2. Okay, or it may want to pass some parameters. So operating system helps in that also. And operating system also provide mechanism for deadlock handling. Deadlock in the sense, we will define deadlock later. So deadlock in the sense the computer may halt due to conflicting resource request from processes, from different processes. Okay, the computer may come into a halt stage due to conflicting resource request from different processes. Okay, so it means the computer comes in a frozen stage. So how to handle such situations? That will also be that will also be the mechanism to overcome deadlock. Can also be given by the operating system. Okay, so let us stop here. So I think it's fine. So what we have discussed, in the sense we have discussed about process management, what operating system does as a process manager. So we have initially we have defined process, we have defined what's the difference between a program and a process, and we have defined what, and we have discussed about the resources that were required by a process. There are two types of resources, like physical resource and logical resource, and sometimes process may require initialization parameters that we have discussed, and we have discussed about the role of the program counter, and then we have discussed about the what is a multi-threading, introduction to multi-threading, and finally we have discussed what are the activities the operating system performs as a part of process management. Okay, yes, thank you.